Hello guys, hello everybody. Okay, so let's just wait for a few more people to join. There's only 6 students. तेरे बिन मेरा हंस। Okay, I think you guys are all familiar with business intelligence. So how do you define the BI? What is the meaning of BI? When people talk about BI applications, what does that mean? Can anybody give me like a basic idea of what BI is? Darshan, Prabin, Adesh, do you know what BI stands for and what how it functions, and like can you give me some examples? Hmm? Hmm? No? I have repeatedly told you what are the different kinds of BI tools that we use that are popular today in the market. Anybody knows? Huh? Okay, so BI, business intelligence, is all about using data to make the analysis and then presenting the data analysis using different kinds of tools. These are called business intelligence tools. They can be either like a spreadsheet or a Tableau workbook or a dashboard. So, or even like Power BI interactive, interactive interface. So what we are looking at when we are looking at BI, we are looking at different kinds of ways in which we can present the data visually to the end user or the client. So last week we talked about data integration. We talked about things such as like what are the issues with manual coding and how data integration tools can solve the issues of labor that is involved in manual coding. And we talked about data integration services and and how important it is to select the right tools to deliver your project. Then we talked exclusively about data and then data ingestion. When you talk about ingestion, what does it mean? what is the meaning of data ingestion? Huh? No? What is the meaning of data ingestion? It's about consuming data as a raw format. In the raw format, if you're taking in the data, the whole data, that is called data ingestion. Then we talked about data profiling, and then data transformation, and then we talked about process management, how to maintain the quality, and then we talked about how data can be transported from one location to another location, what is the most effective way to do so. And then we looked at the roles of ETL, extract, transform, and load. These are primarily with access and delivery and storage of data. Now, this is the same diagram that we talked about. We have SORs, sources of record, here on the left-hand side, where business is gathering input to the data, such as the inputs can be like any transaction interface, where or an online interface or a web interface, where the customer actually interacts with the system. That's when he buys, when he makes a purchase, when he makes a payment, when he buys something online, or when he goes to a store and taps his card on something. So all of that is electronic record or source of record of the data. Then we extract, right? In order for us to make sure we extract the data, and we do what we call access and extract services. Then we do all of this data profiling, ingestion, transformation, and data quality. So all of this, including data transport and data management, these are all the services. These is all under the one big umbrella called data integration. That means gathering the data and putting it in a proper format. That's called data integration. To be putting very smoothly, that's called data integration. All under one blanket is gathering the data and making it ready for analysis. So the analysis part, after we are done with the transformation of the data, if you want to modify some rows, add some rows, update some rows, whatever you want to do with the data, once you do all of that, you can do what we call loading or delivery of the service. So the way you can load it into an external applications, such as like a server. We can load it into our internal servers. So we can load it into our databases or our SQL databases. So we can read the data into a SQL database that can be accessed by the end users or the clients at different points in time. And then we talked about different cloud applications. Then we can load that into different applications. These are all called targets, right? So these can be mobile applications or OLAP cubes. So basically, data integration is taking the sources of the data, and under the umbrella, we do all the data ingestion, transformation, and quality maintenance and profiling. And then we load the data into a target. So these are called targets. The targets can be reports or a Tableau dashboard, for example. So these are all reports, web services, applications. So these are the ones that the CEO or a CFO of a company can actually take a look at these reports or dashboards, and finally makes a decision regarding the company. So the BI applications, it's about creating the content, BI content specifications, and then choosing the right BI application. For example, you need to know whether a report is the best solution at this point, or whether it is good to have a dashboard, or whether it is good to have like a 2 or 3 graphs. That's all. So what is it that you want? What is the layout of a BI that you want? Like, Tableau produces beautiful data visualizations, but it also gives you opportunities and functionalities with the different kinds of visualizations that you can put. And it allows you to build what we call dashboards. Dashboards are nothing but a series of graphs or series of visualizations that can enable you to look at it and quickly understand what's going on with that aspect. So basically, the design of BI is also very should be cleverly done, and you need to understand what are the different kind of visualizations and matching them to the analysis. That means if you want to look at trends through time, okay, how something is changing from 2000 to 2020. So if you want to look at a trend like that, so you need to use a specific kind of visualization. A bar chart is probably not a good option there. A time series graph or a line graph is probably a better option in that situation. But if you want to see how the sales are distributed among different sectors of the business, so you want to ask which sector in my business is generating me most profit. So in this particular case, you can use like a bar chart, or you can also use like a pie diagram to show the distribution of how, let us say, let us say for every $100 of profit, is $60 of the profit is coming from the sale of personal computers, or 15% is coming from the sale of furniture. So what the analysis is giving you is something that you need to put into the appropriate visualization. So matching the right kind of visualization with the analysis is also a key. Now, this is what data integration is about. Data integration, we take the data, we cleanse the data, and we put the data and we store the data into a data warehouse. Once we store the data into a data warehouse, we can redistribute the data into different data marts or an OLAP cubes, depending on how many data marts you want to create, depending on the the business needs, right? So, and then at the end, we want to present the data using BI tools, as I told you again. So the BI tools typically are like a dashboard or a report. So this is for presenting and analyzing the information. So this is the framework that goes from data integration to business intelligence. Next, we look at the application content specification. This is needed to design and document the BI applications before we talk about the requirements. And developing a particular specification is a tool to help in the design, development, and maintenance of any of the BI applications. So the content specification could be stored in a living document that can be modified and updated once we get a new piece of data, or this is something that can be like a consumer can change. Let us say if Amazon is operating a business. So obviously, if any new data comes in, there has to be content. The content must be specified and updated. So the amount of time and the resources that are required to maintain and develop these BI applications, they will vastly vary depending and primarily depending on the volume of the data and the type of the data as well. So if you look at the content specification, you need to look at identifier, the name, the description, the category, what is the category of which you are tracking, and what are the business processes. So this is about specification of the content. Now, if you look at the data comes from enterprise data warehouse such as a data mart or OLAP cube or a spreadsheet or an operation, or it can also come from a relational database structures. So this can be like a Hadoop or a NoSQL or CSV files. So, or a text file, for example. So the data source can have different structures. So sometimes especially when you are working with government data, so government data is usually in the very unfriendly format for most people to use. So because people who are surveying and collecting and gathering the data, usually they are not well educated about the analysis section of BI. So they maybe put it in, like, they may sometimes use space where they need to use comma. They create tab files that are very inconsistent with one another. So you need to look at the different data source structures as well, so and make sure those structures are consistent. And you need to have good table names. Like when you're collecting, working with data, you need to have good names for that kind of tables, like, employee ID, employee not employee ID, employee history database, or like employee records database. So you can create different kinds of tables for each of the departments. For example, you can create a table for marketing department. You can create another table for June quarter, another table for for the furniture sold in United States. So you can create different kinds of tables, and you need to give the tables appropriate names. So, and then column names, right? The column names are usually called attributes, or these are also called dimensions. But on the row side, you have what we call observations. Dimensions on the vertical side, the columns, or these are called attributes, and then the numbers or the observations, they are presented on the rows of a typical data sheet or a spreadsheet. So the status in the data source, it has to be updated. It needs to be created, if it exists, or it needs to be created. And then data is always coming from SORs. SORs means what? What is the full form of SOR? Again, what is the full form of SOR? Source of record, right? These are the record sources. So here, these are all sources of record. These are called SORs. Okay. Now, the content specification, the BI transformations, business transformations, they include different filters or algorithms or rules that you want to apply to the data to make sense of it. So business transformations for analysis is using like a typical KPI. For example, how well a particular department is doing. We can measure that using the profit margins, right? You can measure the growth percentage, or the return on investment, or return on sales. So these are called KPIs. What is the full form of KPI? What is the full form of KPI? Anybody knows? Huh? Well, you are very awfully silent, everybody. Can you guys hear me? Right? Sahil, can you hear me?
Yes,
Can you
sir,
guys
we
hear
can
me?
hear
Can you hear me? But you just decide not to talk. Nobody wants to talk. That's the absolute silence, maintaining pin drop silence. Huh? Very nice. Nobody wants to participate. So, what is KPI? Can anybody tell me what KPI fully stands for?
Key performance indicator, sir.
Yes, that's key performance indicator, like return on investment, or return on sales, or profit margins. So these are all called key performance indicators. So we calculate and measure these key performance indicators and use them as a benchmark to see, oh, okay, the return on investment is more than 7%. So this is probably a good investment for us to do in the future. So you need to make decisions based on the key performance indicators. And analytical styles we can do using OLAP cubes or dashboards or reports. And basically what we are doing when you are using analysis is creating some interactive visualizations. That means the user can actually ask some questions, and based on his choice, based on the end users, so he can actually manipulate and access a part of the data, and you can use the data to create a visualization of his own choice. So that is the analytical strength of BI tools. And we also need to understand the content that is there for a business owner, and who is the business contact when you are gathering, when you are working with the BI application. The owner of a BI is, you need to list the BI team member who is responsible for final delivery of the BI application. That means BI application can be typically a report or a dashboard, let's say. So who is responsible to deliver that report? Who is responsible to deliver the dashboard in time to the end user, to the CEO? So you need to define that BI owner. And you need to also work with BI developer. That means people who develop the tools for business intelligence. And business priority, this is relative to other BI, right? That means which of these tools are more important today compared to other, like, so which of these is a priority, right? So you need to create like a hierarchy of the order of things that you want to do. And you also need to put a lot of understanding into technical level of the effort that you need to put in. And you need to take into account the risks and the complexities and the dependencies that are inherent in the BI system. And you also need to list overall comments of the technical and business staff of all the people who are involved. So this is all how you define the content of a BI specification. So if you want to revise the BI application list, initial list is from the requirements, and then you can revise based on the information that is collected in the specifications. So assessing the scope of the BI application is also critical, and then consolidating the BI applications. And then we need to renew the specifications of the BI, and then we need to create an agreed upon BI deliverables. Agreed upon means what time and what BI deliverable do you want to do? Do you want to send a report, or do you want a dashboard by the end of this quarter? Do you want weekly reports? What is it? Like, you need to agree upon a deliverable. Deliverable means the final product that you deliver to the client. So not necessarily the final product, but it can be like a periodical delivery of a report. For example, if you are using what we call an agile system, have you guys heard of agile system before? Do you know what an agile system is?
Yes, sir.
Yeah, so in the agile system, every 2 weeks after the sprint cycle is done, you may be required to present like a small report, or like, or an update. So that's called a deliverable. The deliverables are usually agreed upon periodically, and based on that, you need to plan in conjunction with the team to deliver that deliverable on time. And the personas or customer segmentation, for example, you want to divide, use the BI and personalize the BI. That means, well, let us say there is somebody who is interested in the overall sales of a company, but he's more interested in the North American division only, right? Because he's operating in North America, he wants to only get the details from North America. So then that is called customer segmentation. You need to, and let us say you want to look at the amount of sales that you are generating from younger people, right? How do you do that? You need to segment the customers so that the analysis of BI can become interactive and intelligent. So you cannot use one size fits all approach. Sometimes it is okay to use put all the things under a single blanket, but it is always preferable to have the segmentation so that you can assess and access the right questions, and based on different segments you can provide. So the customers, the segmentation of the business people can be like we can segment the customers that we have are casual consumers, or descriptive, or analysts can be like a descriptive analyst. So that means when you are an end user, when you are doing the analysis, you may be interested only in the data, like only in the description, like mean, median, mode, and so that is a descriptive way of analyst. Sometimes analysts may be prescriptive. That means they want to use the data and make a prescription, and make a decision to say, okay, let us open another store here in North America, in this Wisconsin, in the city of Wisconsin. So that is a specific decision. That's a prescription based analysts. So these analysts, they are actually not just interested in the numbers, they are also interested in where the opportunities lie for them to grow the business. So that is called prescriptive. So each analysis can be different, like depending on the need that you have. And there can be power users and data scientists. Data scientists are primarily interested in predictive analytics. Okay, what is a predictive analytics? That means you understand, look at the data in the past and predict what's going to happen in the future. So artificial intelligence, neural networks, all of this is primarily a tool, right? Primarily these are the tools that the data scientists use in order for us to predict what is going to happen. So they can help you predict how many sales am I going to have next month, how many orders do I need to prepare for, how many if the orders are going to increase, do I have enough staff members to maintain that supply line. So all of this is different, is personalization of BI. So now let's look at the layout. So now let's just let me just give me 1 minute, I'll be back. Okay, so now let's look at BI layouts. So consistency beats elegance. So what it means is, you don't want to do a beautiful report. What you want to do a beautiful report, but that is not the primary concern. The primary concern is consistency. That means you need to have the reports, like let us say your manager always wants a time series data followed by a distribution of pie chart data. So he wants the way you present the data to be consistent. So that is more important than the beauty of the visualization, so, or the elegance of the visualization. And then dashboards or any BI layout must be very simple. It must be easy to understand. Okay, I'm going to show you, maybe I can show you an example. Okay, let me show you an example. Okay, so what is this? What do you call this? This is a dashboard. This is a dashboard I have created using Tableau for the analysis of whether how the hospital beds are there, whether we have hospital beds, in which countries have enough hospital beds and which countries are suffering because of lack of hospital beds for the COVID-19. So this, by looking at this visualization, you can get a gist of what it is. So you need to select what kind of visualizations are appropriate for you for your purpose. Okay, and you need to choose. You need to still keep it very simple, and you need to locate the key elements of the data. And you also must use the colors intelligently. Sometimes colors, so red may indicate loss, right? Green may indicate profit, right? So you need to understand what color, right? Every color has a meaning, right? It may not be it may not have a true meaning, but as far as human beings are concerned, we associate blue with like peace, or green with like environmental friendliness, or you want to associate red with loss in a business, or green with the growth in a business. So we basically know certain colors that are inherent in our head. So we need to make sure that we are sticking to those guidelines as well. And we need to use the legends wisely. What is the legend? What is a legend? You know, a legend is when you have a graph, you can have a legend where what it shows what that graph is. So everybody knows what a legend is, right? I'm hoping that you guys know.
Yes, sir.
Yeah, so so you need to use the legends intelligently. And you also need to look at any outliers within the data, and you need to flag them. Flagging means like you need to point them out, saying that, hey, look, this is an outlier of the data, and you better take a critical look into this and maybe examine those outliers. Are they really outliers, or is it because you entered the numbers incorrectly? Instead of like 100, you entered 1,000 maybe, and because of that it becomes an outlier. So sometimes you misplace a decimal point. So instead of 10.3, you write like 103. So that may be the reason why an outlier is. So you need to investigate a little bit and flag them as well. So you need to create labels that are easy to follow, and you need to avoid scroll bars. Scroll bars are like, they are irritating. So that means when I look at a visualization, I need all of it in there. Like I don't want to use like a scroll bar like this. This is a scroll bar, right? So this is good for a long presentation, but as for a single slide, I don't want to be scrolling up and down. So, and then the data design for a self-service of BI, there are two kinds of ways in which you can prepare the data. One of them is vertical, and then other one is horizontal. So a vertical self-service BI is targeted for a specific group and functions that they perform, right? So it is targeted for HR team that performs the hiring of new staff, right? This is called vertical orientation, with the same people doing different functions. And on the other hand, horizontal, it focuses on the business process. It is processes of the people that is supported by different groups of the people. All right, that means how many, for example, one process that is supported by people across different business groups, that means number of customers that are being gained by each of the business entities, business groups. That means the profitability of the marketing team, the profitability of the accounting team, or whatever, like, you know. So that is a horizontal way. You look at the whole process, and then you look at the focus on the specific business process. So the project team, when you are building a business model, you should focus on elimination of clutter and using proper business terminology. And you need to pre-build the hierarchies and specify them to business. And you need to avoid inconsistencies in reintroduction of the data. So basically what we need to make sure is you are eliminating nonsense. right? Eliminating repeating data, pre-building the hierarchies and all this. So you need to make sure the data is meaningful and consistent. So the matching types of analysis. So we all know like what a bar chart is, for example. I will introduce you to different line charts or a pie chart. So like let me I'm going to go through each of these individually. I think most of you can recall what these charts are. Can you guys, do you see anything here that you do not follow? Do you know what a heat map is, for example? What is a heat map? Can anybody tell me, Praveen, what is a heat map?
Heat map. Not sure, sir. I'm not sure
Okay,
about that.
no problem, no problem. It's not a. If you don't know, that's fine. Like what? Do you know what a scatter plot is?
Not sure about that one.
Okay. All right. So now I'm gonna please pay attention. Now this is what is very important today.
Okay,
the most important part of BI tools are like using different kinds of visualizations. Okay. Please pay attention. And if possible, like, what is this chart called? The chart that you see on the screen, what is this chart called?
This is bar chart.
Yeah, this is a bar chart. When is it used usually?
It's maybe showing the data.
Yeah, from different categories, and you want to compare the data across different. Yeah, yes, so you want to compare the number of COVID-19 cases in the world. Like now you can put like USA and then India and then China. So now you can see it gives you a hierarchy. Like it tells you, okay, look, camcorders are accounting for the majority of the sales. They are providing most sales, about 1.2 billion. So now this is how it can. This is a bar chart. You can also have a vertical bar chart, right? Like this one is okay. This one is not. Like this one is a vertical bar chart. What is the difference? When would you use this kind of chart?
This can also have another example about when the data is from, like the exact date.
So that data is on the x-axis, right? Yes, on the vertical axis, what do you have?
The total price or total sales. Yeah.
And then from which division are the sales coming, right? Are the sales blue mountain bikes, road bikes, and touring bikes? So if I ask you, when are the mountain bike sales increasing? Like where they increase in road bikes, right? So from over the period from August 2010 to June 2013, right? Which category has, which product subcategory has seen an increase in the sales?
Road bikes and then mountain bikes.
No, not road bikes. They did not show any increase. They are almost the same. They actually decreased. You see, they are big here and they are very small here. The road bikes are like, so the sales of road bikes have decreased. But you see the blue ones are the ones that are increasing. That means mountain bikes, the sales of the mountain bikes are increasing.
Yes.
Yeah, so you need to look at the data and make sense. You need to understand and make an intelligent comment about the data. And what about the touring bikes? What can you talk about the touring bikes?
Touring bikes as well, sir. From July 2012, it has slightly increased.
Yeah, over only the touring bikes sales were even introduced only in 2012, and in the first first few weeks or first few quarters, there was not much increase. But after that, there has been a constant, there has been a steady sales volume generated by the touring bikes. So when you look at the data set or like a visualization like this, you need to tell a story. You need to tell a story clearly. As a data scientist or as a data analyst, your objective is to tell a story. You need to tell a story that is meaningful, understandable, and easy to visualize. So that is the role as a data analyst or as a data scientist. Now, if you look at this, this is another version of the similar chart. Instead of giving you bar charts, we can give you area charts. This can also give you trend analysis. Now, based on this trend, what can you conclude? Sahil, what do you conclude from this area chart? Anybody? Suraj?
Sir,
What do you conclude from this picture that you're seeing on the screen?
you can say that the mountain bikes sales are increasing.
Yeah, mountain bike sales are increasing. Yeah, people are buying more and more mountain
More
bikes.
and more mountain bikes at the time.
Yeah, and what else?
And touring bikes are they getting hike in from January, middle of January 2013, and somewhere between the July 2013 is trying to remain constant.
So from July 2012, we introduced the touring bikes.
Touring bikes, yeah.
So I asked you what a heat map is, right? So a lot of people told me that they don't know what a heat map is. This is a heat map. The one that you see on the screen is called a heat map. Now you can see in the contributions, like now let us say you are running business all over the world, all over Australia. Okay, so different locations. So some locations are very profitable, some locations are giving you a loss. Right now, by looking at this, what can you conclude? Which sections are more profitable?
The North Sydney section is more profitable.
North Sydney.
Yeah.
Now you see the area here, like the one that is very green is very profitable, right? Wollongong is very profitable.
More profitable. Oh yeah, yes sir.
Yeah. Now the one that is very red, right, which is very red,
very less
point. Wilson's Point, St. Leonard's, all these are in the loss kind of.
Loss, yeah.
So the one that is in the middle, which is white, which is neither no profit, no loss. So as you can see, the darker the red, the larger the loss, and the darker the green, larger the profit. So you larger the sales. So basically, profits are usually represented in red or green. Like you can say red. So I am in the red means I'm at loss, right? I'm in the green means I'm in positive. That is how the terminology is used. Now, what is this plot called?
The scatter.
This is called a scatter plot. Now, on this plot, you will on the x-axis you have a numerical data, and on the y-axis also you have another numerical data. For example, height of the people versus weight of the people, or you can see sales. There were sales on the one hand, and the profits on the other hand. So now you can see. Now, if you click here, right? Unfortunately, this is not interactive. Now, if you see here, if you click one, now this one is having high sale about sales of 400,000 and a profit of 600. So that is how a correlation or can be read. Like, as you can see, as this is increasing, this is also increasing. You can see a positive correlation, and at the same time, you can say for different for different departments or different locations, the trend is different, because so these let us say this point and this point, they are having the same sales, but this is providing more profit compared to the other one. So you need to make an analysis based on that. So the other one is called geographic maps. Geographic maps, they can tell you, you can put pie charts on different locations. For example, which country is this one? Do you know? Do you know which country this is? You have France, Germany, right? Spain. Do you know which country this is?
Maybe England, I think.
England, yeah, the country where the world, they rule the world, right? So you should know what country it is. You see, if you look at England, it is so small compared to the countries like USA, India, but they rule the whole world. So that is why you need to respect them, right? So now you see in England, okay, this is the distribution of what, of the sales that are generated using I'm using geographic mapping to see, okay, in England I'm seeing, okay, there are significant amount of cameras and camcorder that were sold, and there is a green also, that means home appliances are sold. So I can give the percentages for this location. I can also look for different locations in Germany, for example. Not Germany, this was in um, this is Germany. Yeah, this is Germany. Yeah, entire thing is Germany, I think. Really, is that the entire thing Germany? Yeah, the big one is Germany. Yeah. Okay, so for Germany, you have a different distribution of pie charts. So that is how a geographical map can be used. But the geo maps can be used in much better ways, like the ones I show you here. If you look here, this map can show you, the darker the blue, the larger the number, right? So if you have more hospital beds are there in countries like Russia, right? Russia has 48 hospital beds. But if you look at country like India is almost like light blue. So that means we are around here. So we don't have that many hospital beds in India. So if you look at countries like Africa, you see they are so much white. That means they don't have any capacity. Hospital, if they get virus, they don't have the capacity to hold the people in the hospital beds. So by looking at a map, right? By looking at what we call a heat map, you can look and you can understand and visualize the data very quickly. Okay. Now this is another form of visualizations. Now you can see the larger the China. So India has the second highest number of hospital beds, right? But is it better? Like which one is better to have? Is it better to have this thick blue or like this in India? Which one is better?
Thick blue.
Thick blue. Thick blue indicates the number of
hospital bed
per thousands of the people.
Yep.
So for that means even though India has a lot of beds, right, compared to, let us say, Belgium, right? But if you look at Belgium doesn't have many people. Even if half of the Belgium people get sick, they may have the capacity to do so. But even if in India, even if 1% people get sick, we don't have the capacity to put them in hospitals. So obviously the size is important, but at the same time the color is also important. So but the advantage of using a heat map is that you can use color to color for one attribute and size for another attribute. And this is another scale that we can use. This is like a tiles, right? We are using it like a mosaic tiles format. So again, this is the same thing, but we can give it in like a square shape. Okay. I hope that is clear. And what about this? Do you know, have you ever seen these kind of graphs? What are these? What are these called? What is the thing that you're seeing on the screen right now? What do you call these charts?
Box plot.
Box plots. Yeah, box plots or box and whisker plots. The meaning of a box plot is what the significance is. 50% of the data points lie inside the box. 25% of the data lie above the box. 25% of the data lie below the box. That means you look at this box, for example. So now you have the median value, you have the extreme values, the upper quartile, and you have the lower quartile below outside the box. So this is the advantages of a box and whisker plot. Now by looking at it, you can look at the percentile, you can look at the quartile, upper quartile, middle 50% of the people, and lower 25% of the people. Okay, so this is how a box and whisker plot works. Okay, so are all the visualizations clear? Right, bar chart, line chart. Line chart is gradually showing the increase, right? Just like an area chart, line chart gradually shows an increase. And then you have area chart, you have diced up column chart, and you have a heat map, a scatter plot, a geographic mapping, or you can have a box plot. So these are the different kinds of visualizations that you can employ for your data science project. Okay, any questions so far?
No, sir.
Okay, so I'm gonna stop the recording.